Hello everyone, we are a group of NUS students and this video is to illustrate what is MapReduce. MapReduce is the data parallel programming to process large amount of data, and it is pioneered by Google. So MapReduce is one of the main components in the Hadoop system, and it is designed to process large amount of data by dividing the work into parallel, small, and independent tasks, which is mainly the map task and the reduce task. The map task will perform the filtering and sorting functions such as sort the word in alphanumeric manner and remove the non-alphanumeric characters from the word. And the reduce function will perform the summary operation on the key value pairs, such as counting the frequency of the word and aggregate the frequency of the word. Before moving to the detailed MapReduce programming model, let us look at the motivation for MapReduce. The first motivation is the need for parallel processing. Nowadays, we have increased data sizes and our mobile apps traces the places we are going, in the banking apps traces our spending habits. If we use single node to process all this data, it will take long time. For example, scan 100 terabytes on one node at 100 megabytes per second will take 12 days. Another reason is emerging affordable cluster architecture. All these contribute to the need for parallel processing and make us to seek solution in large-scale computing. Large-scale generally refers to the use of multiple nodes that collaborate on a few levels to complete a task. The second motivation is the challenges of large-scale computing. The nodes fail, especially when you have many. The mean time between failure for one node is 3 years. However, for 1,000 nodes, it is 1 day, means every day you have nodes failed. The solution is to build a fault tolerance into the storage infrastructure. For example, replicate the files multiple times. Therefore, when you have one node failed, and you can move to another node to get the same files. The second challenge is the low bandwidth network. Therefore, copying data over a network takes time. The solution is to bring computation close to the data. The third challenge is programming distributed system is hard. The programmers need to take care of the distribution and the fault tolerance. The solution for this is the MapReduce programming model, and the system will take care of the distribution and fault tolerance, and the programmer only needs to write map and reduce functions, which is way simpler. How does MapReduce work? Let us look at the word count example. The input file is one sentence, and the sentence will be distributed among the two nodes, and the system will handle it. But for illustration, we are assuming the first half of the sentence go to the first node and second half of the sentence go to the second node. And the map function will produce a list of key value pairs. The key is the word and the value is the frequency. After the list of key value pairs is out, all this list will be distributed among the reduced nodes, and the reduce will perform the aggregate frequency function according to the unique key. Therefore, you can see for the frequency is aggregated to 2, and also for mouse, the frequency is aggregated to 2. And later, the output key value pairs will be print out. Here is the specification for the programming model. We can see the data type is key value records, and programmers need to write two methods, which is map and reduce. Here is an example of the implementation, and we can see the W takes the input text file, which is the text.txt, and the flat map will split the text file into a list of the words according to the space. And for the second W, it will remove all the non-alphanumeric characters, for example, the full stop or the commas. And the key values will use the map function to produce a list of key value pairs, which is the word and its frequency. Here it is 1. And for at this point, the map nodes completes its task, and the W count is the list of the key values with the aggregated frequency, and here this is the reduced nodes. The last one, we will print out the list of the output. This should be the same as the previous example because the input is the same. In the implementation, we use Anaconda and Jupyter Notebook and PySpark to implement it. Here is the links where you can install Jupyter Notebook and Anaconda, and you need to use the Anaconda command prompt to go to the file directory and type the Jupyter Notebook to create a file or access the Jupyter Notebook you previously have.